Hi everyone. We're going to identify the points of discontinuities and vertical and horizontal asymptotes and state the domain and range of these two problems here. So I'm assuming if you're at this level, then you know how to factor, so that's what we're going to do first. So what we want to do is factor our numerator and denominator. So these are both pluses. And 4 times 2 is 8. And 4 plus 2 is 6. So that works. And this one, we need a x. One's positive, one's negative, and a 3. So it's minus 3 and plus 2. Because negative 3 times 2 is negative 6, and so forth. Anyway, we do have a removable discontinuity. A removable discontinuity, also known as a hole in the graph, is actually just a point. It's an x and a y, which is a hole in the line of the graph. So basically when you, let me fix this. It's x plus 2. So when you cross these out, then we have a removable discontinuity at x equals negative 2. You just set x plus 2 equals 0. So and you solve for x, you get negative 2. So we have negative 2. Our reduced equation is y equals x plus 4 over x minus 3. So all we're going to do to find our y is to plug in negative 2 into the x. So that gives you 2 over negative 5, so negative 2/5. Now your horizontal asymptote, the degrees are the same, so you just divide your lead coefficients. So 1 over 1 is just 1. Please write this as a line. That's y equals 1. Asymptotes are lines. Your vertical asymptote is going to be right here. You set your, the vertical asymptote occurs because you can't divide by 0. So this would be 3 here. If you have a 3 in here, then if you 3 minus 3, that's 0, and you can't divide by 0. So that's a line as well. So that's x equals 0. Now your domain and range, I'm going to erase that real quick. We know our domain involves the x. So if we have a horizontal asymptote at x equals 5, a vertical asymptote at x equals 5, we know that x cannot be 5. We also know that x cannot be, from our removable discontinuity, x cannot be negative 2. So if you want to write it this way, I'm going to write negative 2, 5. I'm going to write it in this order. So you're going to go from negative infinity to negative 2, or then you go negative 2 to 5, negative 2, comma 5, or then 5 to infinity. Okay, the same thing's going to happen for the range. Our range is our y, and so we have a y here at 1. We also have a y here at negative 2/5. So it's everything that technically it's y cannot be 1, and y cannot be negative 2 over 5. So to write it, we're going to write, start with the negatives. So it's going to be negative infinity to negative 2, and then or negative 2 to 1, or let's see, 1 comma infinity. So just order your numbers from least to greatest, and you can write it out this way. Okay, next is this one, so we're going to go ahead and factor this. This one's pretty easy to factor. So it's plus 8, minus 1, because we have a 7. And then down here, they're both minus. Has to be a 4, so it's going to be minus 4, minus 1. You can put them in any order. So we do have a removable discontinuity at x equals 1. Okay, we're going to plug it back into our reduced equation to find our y. So when you plug in 1, you're going to get 9 over negative 3, which equals negative 3. So that's your y. Again, our horizontal asymptote is y equals 1. And our domain, or our vertical asymptote, vertical asymptote is at x equals 4. So technically, when you look at this, this means that for our range, y cannot be 1. And for our domain, x cannot be 4. And also up here, x cannot be 1, and y cannot be negative 3, because that's a discontinuity. So when you do your domain, I didn't even write this out right. So x cannot be 1, y cannot be negative 3. So for your domain, we're looking at the x's. So we're looking at 1 and 4. And just put them in order. So you're going to write negative infinity to 1, or 1 comma 4, or 4 comma infinity. And for your range, we're looking at the y, which is right here, negative 3, and it can't be 1. So we're going to start, if you write them in order, it's negative 3 and 1. So you're going to write negative infinity to negative 3, or negative 3 comma 1, or 1 comma infinity. Okay? That's all. Thank you. Have a nice day. Bye-bye.
Class, Miss Shaw's class. Boy, I love math. Miss Shaw's class, Miss Shaw's class.
Don't fail. Watch Miss Shaw's videos for free.